Yeah, so how I got into Julia, I do research in DNA sequencing and RNA sequencing. So the thing that's been happening in molecular biology research in like the last 5 years is that sequencing has become really cheap. So like a lot of assays and technologies have been replaced by sequencing, which is great, except that we're going from data sets that are like 1 megabyte of tables to data sets that are like hundreds of gigabytes of these giant sequencing text files. So I think there's a desperate need for a programming language that's usable by non-experts but capable of generating fast code. Since a lot of people in bioinformatics are, biologists or statisticians who are experts in their fields but not expert programmers. Yeah, so that's my initial interest. So the main thing I've done with Julia is I wrote this plugin package called Gadfly, which I'm going to talk a little bit about. Yeah, so Gadfly is sort of based on this book by Leland Wilkinson called The Grammar of Graphics. And what it is it was his attempt to look at a lot of statistical graphics that are being generated and try to decompose them into common components and build sort of a grammar out of them. So, of course, the most popular implementation of this is Hadley Wilkins' ggplot2 for R. So Wilkinson's original implementation is a Java program called Invisit. I don't think that ever became really huge. It was a proprietary software, and the licenses were like $10,000. Even though it wasn't really sophisticated visualization system, much more than anything else at the time. You also could write like a bunch of XML. Yeah, so let's jump into it. So like the simplest sort of plot you can make in Gadfly, it looks like a lot of other plotting software. You just call plots X, Y, pass some data to it, and it makes a scattered plots. So Reveal did something bizarre to these plots, and the fonts are a little bit mangled. Usually it looks a little bit better. So yeah, so this is a plot in Gadfly. This is all in iJulia notebook. Yeah, so it's outputting SVG. It's some fancy SVG, so you can. Oh, great. Well, I'll show you an IPython notebook today.
Which browser are you in?
I'm in Chrome. Okay, maybe I should just show you the notebook. This is pretty terrible.
That's usually the story with IPython implementation.
Yeah, I stopped even trying to use slide mode after a while.
Oh yeah, I'm just going to do the notebook because.
Yeah. And if you increase the magnification, it should work pretty smoothly in Chrome.
Okay, let me try to do that. Is this good?
Yeah, perfect.
Okay, so I'll just scroll. Yeah, so it's generating SVG. It's sort of fancy SVG because it almost always works.
Something you changed a few days ago and made that happen.
I was trying to fix some other bugs. I'll show you my plots. Yeah, but really in Gadfly, this is really just shorthand. The full specification of this plot looks something like this. So it's a bunch of like scales and statistics and guides and stuff, which of course prompts the question, what is all this stuff? Yeah, so sort of the picture I have in my head of Gadfly and grammar of graphics in general is sort of like this. There's this toy that this company makes called Little Bits, and they're like these little things that you can plug together and make tiny devices with. So the idea is like kids can learn about electrical engineering without like having to use a soldering iron or worry about like shorting components out. So I think of Gadfly as sort of the same way as defining some sort of reusable components that fit together in a well-defined way and that you can build a wide variety of plots and visualizations with. Though, I mean, just like this, it's by no means like any visualization. To do that, you need a level lower, you need a soldering iron. Yeah, so components in Gadfly work sort of the same way. So this simple scatter plot, it looks something like this. It passes through several levels. So if this is the data, we bind it to what's called aesthetics in Gadfly. And aesthetics are like named variables that define the connections between the different components in the plotting system. So you know, components are sort of like functions, except a level higher because they work on named inputs and outputs, and they're applied in sort of defined order.
In this specific instance, what is a component and what is an aesthetic?
In this specific instance? Yeah. Okay, so the labels I put on edges, those are aesthetics. All these boxes, those are what I'm calling components. Yeah, so because these fit together in a defined way, all you have to do is just add new ones to the plot function, and it sort of works. Yeah, so the order that you add these things to the plot function doesn't matter. So like basically you can put the plot function in any order and you get the same plot. Yeah, so I'm going to show some more example plots. I should say I'm plotting a bunch of example data sets that are from the R datasets package, which is a very nice place to get example data. It sort of collects like all the example data from all the R packages. So yeah, so this is like the famous data set measuring iris features of species. Yeah, so if you bind new aesthetics, you get different behavior. So here, this was like the last plot, but I'm binding categorical data to the color aesthetic. Yeah, so the other important components are statistics, and statistics are sort of like you think of plots that you normally draw, like box plots or density plots. What we've tried to do is extract the actual summarization or computation out of those statistics and separate them from the drawing routines, which makes the system much more powerful. So like here's like a sort of heat map thing drawn one way. This data set is like some macroeconomic stuff of different countries over a span of 1965 to 1990. So the x-axis is GDP, or the x-axis is here, the y-axis is GDP, or actually percent change in GDP. And you're sort of drawing a heat map of what countries changed how during those years. But if you bind it a different way and use a different statistic, you get a different plot, even though it's sort of using the same geometry to draw it. So this is the same data set, but instead we're doing, so I've defined the statistics, I should say. So here I'm using the summarization statistic to accumulate how many things fall within a bin and colored that way. And if I take that statistic out, I get a different plot. So here I'm directly plotting colors that are bound to percent change.
How do you specify that, sorry?
Oh, sorry. Yeah, so this first plot, it's changing basically because I'm changing the statistic. I'm changing how the data is summarized and also bound to aesthetics, even though I'm using the same rectangle geometry. I wonder if this works. Okay, so that sort of works. Yeah. So here's a bunch of warning messages. So one thing I should mention is that I've tried, at least with recent versions of the Gadfly, to make it sort of type agnostic. So, and it's not limited to just like plotting floating point numbers like a lot of systems are. It's because we have sort of a rich type system. You can plot anything that sort of behaves like a number. So here, this iris data set, it's not annotated in any way, but I happen to know that it's centimeters. So I can use SI units to actually make unit-fold types, and I can still plot them, even though we might want to change how it's printed a little bit. So that plot's perfectly fine. And there's no special cases to handle SI units in Gadfly. It just sort of works if you define the right arithmetic operations. Yeah, so this also works mostly for time. So here's George W. Bush's approval or disapproval rating. Yeah, so these 3 lines, I'm just converting columns into time objects. And here, I've bound the x aesthetic to date and the y aesthetic to value, which is approval or disapproval. Yeah, and so it just sort of works, even though it's not primitive numbers that I'm mapping along the x-axis, but dates.
And in particular, if the dates were not evenly spaced, you would see that reflected in the plot, you're saying, right?
Right, yeah.
So if you had a gap in sampling, that will show up.
Yeah. So like, I mean, like these data points aren't specified as 2005.5. It's specified as, you know, whatever month, whatever day. Yeah, and it knows how to map those. Yeah. So more recently, I've been adding stuff like faceting. So I've sort of taken a different approach to faceting in Gadfly. Rather than introduce a whole other layer to the grammar, I've sort of tried to fit it in with the existing grammar. So the insight is that you can sort of think of facets as a geometry that's sort of recursive and draws smaller plots. So that's what I've done. I've defined a subplot grid geometry, and what it takes is another geometry, and it'll recursively call plot and draw smaller plots and work out how to align them and how to compose them in there. Right. So this is. I mean, I can show you. So unfaceted. This is like. It's too much for Chrome to handle. Yeah, so maybe I will try that again. Yeah, so faceting, I mean, it works like any other geometry, except the aesthetics here are X group and Y group, and you bind some sort of categorical values, X group or Y group, and it splits it into subplots this way. So here's one binding Y group. This is vocabulary versus years of education, and I've split it up by male versus female. Yeah, so you can bind X group and Y group at the same time and get a big grid, but I was struggling to come up with an example that actually fit on my slides, since it just sort of explodes into a gigantic array of plots. Yeah, so let's
get two plots in there.
Oh yeah, okay. So let me take this apart a little bit. So it doesn't crash. So let's do like a simple set of box plots first. Okay, so these are box plots, and on the x-axis it's years of education. I don't know what the units are on the y-axis, but it's some measurement of vocabulary size. Right, so that's a basic box plot. But to go one level deeper, I want to split it up by some categorical variable. So I'm going to bind y group to sex, and then do the subplot grid geometry. And it takes as a parameter the geometry that's used for those subplots. Yeah. Yeah. So you can make some pretty sophisticated arrays of plots that way.
Is there control over the text, like vocabulary by sex? Could you make that say something different?
Yes. This will maybe work. Oh, what's this guy?
I make that mistake every time.
Yeah, I wonder about that distinction if it's not work. Yeah, so changes the goals.
Really slick. I wanted this in other plotting environments forever. Good faceting.
Yeah, it's not perfect yet in Gadfly. You can still like use some issues, but it's improved a lot.
Do you have control over the relative sizes of them, or are they all kind of the same? Like, could you make one of them twice as big or twice as tall as the second?
I think there's some. I don't have very good support for that yet, but I at least have the mechanism now where I can which I'll talk about in a bit. So I have a little bit of support for not constraining the axis to be the same. So let me talk a little bit about the back end stuff. there's a few different packages that are involved. One of them is color.jl, which is it's become one of my favorites because it's a lot of immutable types and a lot of good use of multiple dispatch. I started this, and I sort of got to the point where people that actually know stuff about color imagery, like implemented some really cool, obscure stuff that I'd never heard of. So it sort of reached a point where, as far as I can tell, it's the most complete color package in any language. I may be wrong, and I'd really like to know if I was wrong, because I can steal features from that library. So yeah, so there's a lot to talk about with this library, but I'll just touch on a few things that are useful for visualization. One of them is perceptually uniform color spaces. So what this is our perception of color. We're not like neutral observers of color. We have particular frequency response curves. And you can plot this here, since we have this data in the color package, of course. So of course there's three sorts of photoreceptors in our eyes: long, medium, and short. They're labeled usually, and they have sort of this x-axis is wavelength in nanometers, and they have this particular response curve.
Are those negative numbers?
Yeah.
That can be right.
Yeah, I don't know.
It's the particular basis for this color space is defined as well.
Okay. Yeah.
Wait, what?
Yeah. It's just a basis function. The neural model is just a basis.
But it's supposed to be the empirical response curve too.
No. The one that works is XYZ. That's the actual color reception. This is the LMS color space.
Yeah.
Okay, so I should slide this on XYZ. Yeah, so there's like tons of convert methods in colors. One of the main things, so you can pretty much convert between any pair of color spaces. And there's like, I don't know how many color spaces we have now.
You got two Ys. Yeah.
Well, yeah, it should be Z.
And
The third one.
Audience length.
Oh, so maybe this is the right one, yeah. Okay. Yeah.
No, man.
Okay. Right, so yeah, like humans have better color vision better color vision than most mammals, but it's mostly because we started eating fruit and needed to tell what fruit was right. So it's not really good at like mapping data to that. Yeah, so we have a few perceptually uniform color spaces implemented. Here, so let me show you a comparison. So this is HSL, which is like the common one that's implemented in SVG and HTML and CSS and like every graphics program. This is lab color, which is one of the standard perceptually uniform color spaces that was standardized in 1976.
What does perceptually uniform mean?
Oh yeah, so let me explain. So they both have a hue parameter, and I'm varying it by constant steps. So this isn't the highest quality color reproduction. You can hopefully see that like in this you have some like very obvious gradations, yet when you get into this green period, like you sort of can't tell the difference between them. Whereas lab, like the hue parameter maps much more closely to what our perception of hue is. So this looks to us like more continuous steps.
So the uniformity there is in like least noticeable difference, kind of like it's like the colors are like more densely packed in places where we can better perceive the differences.
Right. Yeah. And further away where you can get less perceived differences. And the same thing's true. They both have sort of a lightness parameter, which I mapped on the y-axis. But if you look at like HSL, like this like doesn't really look the same lightness as this, at least not to me. You know, it's the same lightness parameter.
You can get a little more screen real estate if you go to the view menu and hide toggle head or toggle toolbar. Okay, there you go.
You know, it's like the presentation mode in Chrome. That helps.
Okay.
That helps. In the view. The presentation.
Okay. Yeah, so we have a variety of perceptually uniform colors. And this is a good way of generating, if you want to actually map data to hue, this is a good way of doing it. The other way you want to map data to colors is sort of in a categorical way. So a lot of packages that even do have a somewhat sophisticated notion of color and use this more sophisticated color spaces don't do it in a very good way. So for categorical values, they'll just pick evenly spaced hues but keep the other colors the same. Just sort of not really the problem that you want to solve. But luckily we have a better solution, I think. So we actually have an algorithm in colors that will choose a set of maximally distinguishable colors. And this is something that Tim Coley did and helped me port to Julia. So yeah, so you can give it a bunch of choices of the different parameters, and then ask for, in this case, 10 colors, and it's going to generate 10 colors that are maximally distinguishable. And we actually have a wide array of color difference formulas implemented, so we can do this pretty well.
So the Daniel's version is about 100 times more sophisticated and tunable than anything I've ever looked at.
So I think like one of the main things we added was so a lot of plugin packages they choose their colors without regard to color blindness, which is a pretty significant proportion of the population, especially the male population. So I don't know what it is, like 5 to 10%. So deuteranopia, that's the most common form. But we've implemented a simple simulation of that. So we can optimize the distinguishability of these colors after transforming them into this sort of reduced skin. So if you simulate color blindness and do some colors, you get a different set. So this looks different from this primarily because like these are terrible choices if you're red-green colorblind, and it avoids those choices and it chooses a lot of yellows and blues and browns and things that you can't distinguish.
Do you have a distinguishable colors function that like has still distinguishable colors when somebody prints out your color plot on a grayscale printer? Because I had this very nice paper with a gadfly plot, and somebody printed it out.
You can pass in a set of seed colors that what it effectively does is load the queue with those colors at the beginning, and then all future colors will be chosen to be maximally distinguishable from those. So if you basically choose the paper background as one of your seed colors, and if I remember correctly, there's no limit on how many seed colors you ask to basically avoid. It will then it doesn't avoid those any more than it avoids nearby overlaps between any other pair of the groups. They're not special in any sense. But
you could also maybe do that by picking colors with very different lightness, using a different color space, maybe.
Yeah, something I just like. I mean, I like my colors in my PDFs, but then people tend to print them out, which is a waste of paper. But they do that.
What's the advantage of making both grayscale prediction?
Yeah, you could do that. I mean, transform is an arbitrary function that takes the color back to another color. So I mean,
grayscale prediction would be awesome.
It would be interesting to use jump to try to anything is possible.
I mean, and the version that Daniel wrote, I mean, you already can actually choose a range of, with hue saturation value, I think are the 3 parameters, right? So you can specify that all the colors should be within some band of hue or something like that, right?
Yeah, so I mean, like all those parameters you can limit to some set.
Right.
Gadfly it's implemented. I wrote a graphics layer which I use to implement Gadfly. It's called Compose. I'll talk a little bit about that since that'd be pretty important to how Gadfly is implemented. So what is it? It's sort of a declarative graphics system, which is a level higher than sort of like the logo, set in the turtle, circle sort of drawing systems. And it's basically based on trees. I won't go too much into depth to it, but like here's a really simple example. The tree is specified where every internal node is of type context, and then the leaf nodes that hang off of it are either like shapes that you're drawing or properties that modify the subtree of that node. So here, I have a root node here. I'm applying stroke that affects the whole tree, and then I have 2 subtrees here, which draw 2 circles of different colors. And it's based around a compose function is what I call it, which is basically make a tree out of something that's vaguely like an S expression. So a lot of the drawing code and Gadfly is like big S expressions, and then you can compose on it.
How is that specifying that the circles should overlap? I don't understand.
Oh, so this is I have 2 circles. If you don't assign units to this is like a 3rd way across. screen. This is like 2/3 way across the screen, and then the radius is like here.
Okay.
It's like ticks.
Maybe a little bit, yeah. Yeah.
Is there a way to change the plotting coordinate system, or is it always 0, 1, 0, 1?
Oh no, you can change this. Yeah, and that's sort of the main. One of the main things it's designed to do is to take into account all the changes in coordinate systems that you have to do in drawing sort of complex figures. Yeah, so here's another example. This is a principal triangle. So yeah, so it's not very many lines of code. It's not hard to draw this in any drawing system, but I think it illustrates nicely what I mean when I refer to it as a declarative drawing system. Because like a regular function that you use to draw a Sierpinski triangle, it's got this recursive call, but it's going to call it 3 different times to do 3 sections of the Sierpinski triangle. But if you notice here, I'm only calling it once, and I'm just sort of recontextualizing what I get out of that one call. So here it's actually not a tree. I'm building a graph. So it's only ever making one triangle and just like putting it in different contexts. So when you go to draw this, it just does a depth first traversal of that graph, and it runs into that triangle a bunch of times in different contexts and draws it in different places.
Do small changes to one of the numbers make it really funky?
Oh. Yeah, so and one of the problems that it's designed to try to help with is these coordinate system changes. The other one is that in like actual figures and graphs that you're drawing, you have to mix coordinates a lot. If you're dealing with text especially, there's a lot of things that are specified in absolute coordinates and a lot of things that are in relative coordinates. So there's a pretty sophisticated notion of units in Compose. So W means half the width of the parent context. Whereas I also have 1 centimeter here, which means 1 centimeter. So here I'm drawing the same composed graphic at different sizes, but this circle is specified in absolute coordinates, so it stays the same size, whereas the outer one is relative coordinates, so it expands. Yeah.
So does it have a built-in idea of the paper size or something, or like what does a centimeter mean? Like it's on a projector right now.
So SVG has a notion of
I see here.
Yeah. So the bigger question is, what does a pixel mean? I think, and I'm sort of like scaling by some common value there. Yeah, so I can write to SVG, PostScript, PDF, PNG. PostScript, PDF, and PNG I'm doing through Cairo. I'm generating my own SVG, which has a number of benefits. One of the most immediate ones is that I'm much more efficient at generating SVG than Cairo is. So here I'm drawing the same plot, one using Cairo as the backend, one using my own SVG generator. So you can see uncompressed, it's like 1/3 of the size, and compressed, it's like half the size. And this is just because like Cairo's not necessarily bad at SVG, it's just a very low-level system, and SVG is a high-level system. It's sort of this fundamental inefficiency from jumping from low level to high level. It's got to repeat a lot of stuff because it doesn't know the larger context.
Is it also better performing?
Performance?
In terms of text generation?
I haven't done a ton of work optimizing it yet, so it's probably not as fast as drawing. It's better. Although with SVG, if you put a ton of geometry into it, it's more like how fast the browser can draw. How fast you can do it. Yeah, so the other cool thing about generating your own SVG is you can sort of exploit some obscure features of SVG. So one of the things I have in Compose is you can actually embed JavaScript in SVG. So here's a really simple example. So I have a JS call property, and you can just like stick some JavaScript in there, and it's going to assign a unique ID to whatever this turns into in the generated SVG. Call that JavaScript property. So here it's just a function that transitions to a random caller that recursively calls itself. So if you click on it, it creates this hypnotic display. Yeah, so obviously you don't want to write a ton of JavaScript in these strings like this, but it's really useful if you want to hook up JavaScript event handlers. So like when you click this thing, I want to call this JavaScript function, I need to find something else. And that's what I use to implement panning and zoom. Yeah. Another big advantage of sticking everything in the SVG, which is what it is by default, is it's super easy to include these interactive plots in your website by just using an object tag instead of an image tag. You can still use an image tag with SVGs, it just won't be dynamic. So there's that nice fallback if JavaScript is disabled. Yeah, so the next thing I'm going to talk about is stuff that I've merged in the last couple of weeks regarding layout. So one of the things that's frustrated me in the past with plotting libraries is that they have a very rigid notion of how things are laid out. And this is despite having a pretty long history of layout problems being researched and practical solutions. So obviously we've had tech for a long time, we've had browsers for quite a long time, and they've become very sophisticated in their notion of layout. So you can have alternate layouts if you're looking at it on the phone versus the larger screen. So also operating systems are starting to integrate like these constraint-based systems where you can do very sophisticated layouts and dialog boxes. Yeah, plotting libraries are like, if you shrink the size of the plot, it's just going to like overlap little labels and it's just going to look like garbage, and it doesn't even know what it's doing because it's not smart enough. So I'm starting to try to fix this with Gadify, I hope. So the particular way I tried to formulate this as an optimization problem is like this. And so I realized part of the trade-off with layout is you don't want to do anything that's really unintuitive. Like you don't want like to resize it and have things totally rearranged. What you really want to do is simple things like word wrapping and having things moved into new columns. So everything is pretty much laid out in a table, except each thing in the table might have multiple different ways you could lay it out. And what I'm trying to do is, if this is the plot here, and this is like labels and color keys and stuff, there's going to be multiple ways of laying out the color key. What I want to do is try to find a set of layouts for each of these cells where nothing's overlapping, so it's a feasible solution that I'm maximizing the size of the plot. Yeah, so I've implemented this in Compose using it's a table system. It's easy to formulate this as a mixed integer program, which I'm solving with Jump. If you have Jump installed, but I also have a backup brute force solver, which is it's totally adequate for plots because there's usually just like a dozen or 20 combinations that you have to iterate through. But you should, if you have Jump installed, you should be able to solve larger layout problems. Yeah, so the main thing this does so far is so this is the same plot. I'm just drawing it at different sizes. So if you shrink it, it figures out, oh, to make a feasible solution, I have to wrap this over here. And because you're trying to maximize this, it knows I'm not going to wrap it to 3 columns because I don't have to. And I want to maximize the size of the graphic. So it also
that'll save me about 500 hours over the next
Yeah, so what I've implemented now is like wrapping keys to new columns, rotating. These labels will rotate if you shrink them enough. That sort of thing.
Is it crazy to imagine a system that would allow you to, as a user, do like what PowerPoint lets me do, which is kind of just mouse over and make things bigger and smaller to make it just the way I want?
It's conceivable. I think it's definitely possible. Yeah, it just depends like what the best interface supposes is.
I wanted to just guess the right thing the first time. I don't want to have to like, this is perfect. You did the right thing.
If I believed that that's always doable, I would not have asked my question.
I know.
Yeah, so I mean, realistically, no matter how good it is, you sometimes have to edit the graphics, which was like part of the motivation for making my own SVG generators, because it generates really clean, simple SVG that you can even edit in an editor, unlike the stuff you get from Cairo, which is just like a gigantic mess. So now that I have this solver, it also, I mean, it has a new level of insight, the plotting function, because you can still shrink it so small that it can't draw it, but now it knows that it can't draw it, and it's going to give you a warning. Yeah, so it's going to output garbage and say, look, I can't draw this correctly. There's no feasible solution. Yeah, so the other layout problem, which is demands some different methods, is label layout. So you can ignore all this code. I was just drawing a little diagram. All my diagrams are complete now. Yeah, so I mean, the basic problem is you have these points and you like to assign labels to them. But you need to position these labels so optionally they're not overlapping. So like, I mean, like most of these interesting layout problems are NP hard, but yet there's usually a solution that's pretty good. So this is no exception. And sort of the pretty standard way of solving this is through simulated annealing, which again, so you get pretty good label placement. And the default behavior is if they can't figure out how to place a label without overlap, it's just going to hide it. But there's a penalty in the optimization function for hiding the label, like a pretty big penalty, but not as big as overlap. Yeah, so like this plot is mammals' brain size versus body size to show that humans aren't that exceptional.
Can you do that same thing for lines? So rather than having legends, you have that.
I don't know that yet. Yeah, so the label layout, it only sort of knows about points and labels. So I don't have it yet.
Because like, yeah, my next somebody does that. So I always end up wanting to escape this.
Yeah, I really like to do that.
If you zoom in, will more labels show up there?
I don't have that implemented yet. I'm going to do that soon. But of course, I broke the Zoom function. At least the labels and the lines.
So which way makes humans' brains better?
We've all seen this work for real, so we know it works.
Yeah, so that's basically Gadfly and Compose. The last thing I was going to show. Yeah, so along with this being the first JuliaCon, this is the first year Julia has participated in Google Summer of Code. And there's some really good stuff going on. I wanted to show a little bit of React. So one of the students is working on this system called React, Shashi Agabda. And GSOC's only halfway through, but he's made really amazing progress with it so far. So you can do some cool stuff. So what it is, it's a general purpose signals library that's it's based on the Elm programming language. And functional reactive programming is the paradigm. And this interfaces very nicely with a system that's added to Python recently, their widget system, which sort of allows you to display widgets and have bidirectional communication between that widget and the Julia process. So here's R is a simple signal that's assigned an initial value of 1. XS is just an array of 10 random numbers. And now I'm going to lift a function into a signal. So what this does is I have a simple anonymous function here. I've sort of overloaded R a little bit, but and I'm attaching it to this R signal and attaching some computation to that. So now I can update this R signal with a push function. It should, even though this wants to scroll way down for some reason, this array is updating as it's being raised to a higher power. It does that automatically. So that's kind of cool, but you can do more sophisticated things. Yeah, so one of my favorite sorts of plots is hexbin plots, because it's, I see a lot of plots that are point clouds where there's so much overplotting that I don't know what's going on. So hexbins are like a really good remedy for this. It's unfortunately not implemented in a lot of libraries, but I do have it in Gadfly. Yeah, but the one complication of hexbin plots over point plots or scatter plots is that I have to choose a bin size now. So fortunately with IPython widgets and this React framework, I can sort of tinker with the bin sizes interactively. So I've created this slider signal, 2 slider signals for X bin count and Y bin count. And I've used lift to turn the plot function into a signal and connect it to those 2 bin count signals. So now I should be able to change this, and it's going to increase the bin count to 3 jobs. Yeah, so that's pretty satisfying because it works with no special support from Gadfly. It's it's a well-designed general purpose system, and you can sort of do a lot of stuff like this with it.
Do you have any guess about what the major source of latency is here?
Yeah, so I mean, it takes a little while to rejob, partially because this is like a data, it's a fairly large data set, like 20, 30,000 points in it. But also because I put like zero effort into optimizing any of this. So I think it could be a lot faster.
But with smaller data sets that can plot pretty quickly, is it like fairly interactive if you drag it around?
Yeah, I think so. I wonder if we could, we should try to do this.
Try like plotting a sine function.
Oh,
Just
make it depend on some arbitrary way.
yeah. Yes.
But you'd have to signal on network.
Let's just change in the range across the display. It's still not very fast. I think it's evaluating at a lot of points. I'm not really sure. But yeah, like I said, I cannot profile this problem. Yeah, but you can sort of hook this up in arbitrary ways. There's still a lot of work to be done to make it usable, but it's pretty handy. Oh yeah, so the last demo I was going to show you. This is not limited to hooking up plots to sliders, even though that's really useful. Can we turn these lights on? This might look better.
You're going to lights down more?
No, on.
Oh, on.
On.
It's on the screen from.
Oh,
great. On the.
Yeah, so I was trying to come up with a general purpose demo of this React system. And what we thought of was, why don't we try to implement a theremin in Julia? So if you don't know the theremin, theremin was like a mad scientist, Russian engineer, inventor, and he came up with this musical instrument that was unique in that you don't touch it. It's just antennas, and how close your hands are to it changes the pitch and volume. So what I'm doing here is MacBooks have an ambient light sensor that I use to blur the screen with the lighting. So I have a little C function here where I'm reading that value, and I'm using Shashi's system to lift that into a signal. Now I'm using audio I/O, which is meter.dot impedance, to play a sine wave and varying that based on what the light sensor is. So,
all in 4 lines of code.
Theremin's notoriously hard to play. There's only a few people who are really good at it.
Code a lot bigger?
What's that?
Nathan just needs to code a lot bigger?
Oh, yeah.
Yeah. Is that code in a gist somewhere?
Not yet. I could do that pretty easily. Yeah, so it's you also have to, there's a little bit of C code here to read that signal, and it's, OS X specific. Yeah, that's React, and you have like a built-in color, so it's possible.
Yeah, I was curious if you have like an arbitrary objective function for that layout optimization, or just in the example you were trying to maximize the size of the graphic, but I was wondering if you could have a penalty for a word graph versus like relative to the value of an extra pixel in your graph and so forth.
Yeah, to some extent, yeah. So I didn't talk about like the general mechanism I'm using to implement this. So I said compose was like a system where you're specifying a tree and then it's drawing it. So the way I'm doing this is you have to know the absolute size of what you're drawing it to do this. So I'm using part of the tree is not materialized until draw time. So I introduced the notion of like a context promise. So it starts drawing it and then gets to that point and then decides what to do. So you can implement like any sort of layout system using that mechanism. So like this label layout is a totally different optimization. It's using the same thing.
One of the things that I've never understood that I'm sure you can help me understand is so I'm starting to get it's like you have the different aesthetics, which are kind of like different properties of your graphic that you can then map to different varying values in your data set. Basically, you're kind of like linking those things together, right?
Yeah.
And so that part kind of makes sense. But then there's always like the last argument in the plot. It's kind of this freestanding geom dot line or whatever sort of argument. How does that? I mean, it kind of it sort of makes sense that like I just replace that with the type of plot that I want to draw, sort of, and like some of them I can put more. I can sort of stack up multiple of them. What's the kind of conceptual underpinning that like helps make that part of it make sense, and I don't just feel I'm like replacing something without anything.
So you're particularly talking about like stacking up multiple geometries, or just like how does geometry?
Well, I guess like why is it that that's not a like geometry isn't an aesthetic that you're like mapping a constant value to, or like I get that. I'm kind of just trying to figure out how it fits into, and like what the other ones are all keyword arguments, and that one is not a keyword argument.
Yeah.
And I feel like there's probably like a really clean conceptual reason why that would be that way.
So conceptually, I'll say that the aesthetics are representation of data, and the components like the guides and the geometries and stuff are all at some level functions that operate on the data.
Okay.
So like geometries and guides are always like the terminal function that actually draws something, but then you have scales and statistics which alter the data in some way. So it's sort of this pipeline where the data gets scaled, then it gets transformed by a statistic, and it gets drawn by the geometry, but it's all operating.
And can you always put multiple geometries kind of arbitrarily, or?
Yeah, so it's not obvious, but what it's doing when you put multiple geometries is creating multiple layers. So there's a notion of a layer, and a layer is just something that has its own statistic and its own, potentially its own data and its own geometry. So you can put as many as you want, and you can have different data layers too.
So just a question about so is there a way to compute statistics externally? So often, they're going to be the most computationally intensive bit, and you might want to use it against something else.
Oh yeah, that's a good question. There's not a good way of doing it right now. So like I have a density statistic to do density plots, but it's a custom wrapper thing. So I think the solution, it should be easier to make sort of ad hoc statistics. That would be the best thing.
And to extend as well, if you're building some sort of model class, you want to be able to output.
Yeah, definitely.
There seems to be a question though of at what point should the statistic be really in the plot as opposed to a separate statistic step in your computation.
Yeah.
For box plots, we needed that, and Daniel added it in. For box plots, now you can specify all the points, all the 5 points of the box plot externally.
Right. Yeah. So by default, it would force box plot statistic in it, which would just take X and Y and compute a bunch of values like upper fence and hinge and middle. And of course, with box plots, there's multiple ways you can do a box plot. There's like one that's most common.
Do people ever ask for 3D graphics like the Satinsky sponge?
Yeah, people ask for 3D graphics. They don't realize like how big of a project that is.
I'm already scared of it.
Yeah. Yeah. So the difficulty with 3D graphics is like everything in the back end is different. So it'd be great to have a 3D graphic system where it has a similar front end, but unfortunately, I doubt there's much that you can do.
I mean, it seems to me that the real strength of Gadfly, compose and color obviously are more generic, but the real strength of Gadfly is that it's presentation of data. And I've always found that presentation of, if you try to do a 3-dimensional version of a 2-dimensional plot, it just comes out awful. I mean, the kind of stuff that Tim does, where you're visualizing things in 3 dimensions, but there's no axis on it, is very different.
Yeah, that's something Nash is doing. It's good for that.
Right, exactly.
All right, thanks, Daniel. 20-minute break. Let's resume.
We also have bindings to PyPlots, new plots, just new bindings to Boca, the Python plot. I think it's good to have a number of options for plotting, but one of the main concerns that we've had is that there's basically no code being shared between any of these packages. So I think one of the major things we need to discuss is what can we try to factor out, and how can we create a somewhat consistent plotting or graphics experience for Julia users without trying to force anything. So if anyone has any ideas, sure. Yeah, so I think the other concern that I hear a lot is about discoverability. If you come from MATLAB or R, you might expect to be into the prompt to be able to type plot, to be able to plot things. But of course, since we have a bunch of different ways to plot things, there's no obvious one. So if you try to plot things, you'll be, okay, what do you want to use? Winston or Gaston or Gadfly or PyPlot or Vega or Boca, which that doesn't mean anything. So you have to do, it's sort of the same problem with the logging libraries. We have to do like research before we plot something, which isn't a great situation.
It just occurs to me that the one thing we might do is just, I don't know what happens now, but I think it probably does this plot not bound.
Oh yeah.
We ought to be able to at least point people to one or two or three of these right now.
Yeah,
so
like have a stub. Yeah. Like I know Ubuntu, like if you don't have some command installed, it'll be like, oh, you're trying to do this, maybe you should try to install that first.
Right.
So that could help a lot. Yeah.
Even having the data arrays, right? I think that happens. So like, there's something you can type like NA or something that if you try to do, it actually says like maybe you want to install data arrays. I don't remember what it is. I think, basic people would know better. Isn't there something that just prompts you to install the data arrays at some point?
I put in some of these functions, some of these error messages in, like if you're computing standard deviation and you have like bands, like if the answer is NaN, I'll say like the answer is NaN, but like there's a warning that says like you meant like missing data.
Yeah. So it definitely seems to be.
The REPL could intercept undefined variable errors and do like a package search.
Yeah, I was just thinking that it might make sense to index all the exported functions in all the packages, and then you type something and you can type a package. It would tell you this function is in this package.
Yeah. With plot, you could be even more cool and actually show a sort of sample plot from MATLAB. You can click on the one you like. That's usually what people want. They want to know that plotting is possible.
For $4.99, you can buy option A.
You can also just ship with dot plots and then.
Oh, nice. Yeah.
Text plots.
Text plots.
Yeah.
I use it all the time.
The dot plots is like that, but with using the Braille characters to get slightly better resolution.
Do they have color in that yet?
You need to add the color pattern.
Yeah.
So maybe Jeff could comment some on, I mean, one of the, I think, best hopes for sort of the possibility of some code sharing among different, plotting packages is the idea behind base.graphics. So, but yeah, I think so far that's really only being used by things that are sort of Cairo-based, basically, right?
Yes, yeah.
So you want to comment further on what vision you might have for that?
The only thing I can think of is to have a base set of types for geometric kinds of things. Compose and Winston both have types like that inside. And I've seen, in one of Kendo's notebooks, I know he read some shapefile and then he immediately had to just convert all the data to some different data structures just to be able to display it. We should be able to cut out that step.
Yeah, it was the exact same data structure.
Yeah.
I mean, in this case, it was slightly different though, because I was actually reading it from a file. So the one data structure was actually like the compressed file one. So I don't think we can necessarily get rid of the compression.
Well, nevertheless, you should be able to.
Yeah, you can expose APIs.
The standard way to represent geometry and then display it using whatever is available.
So what are the holdups blocking that?
I don't know. I think maybe we just have to sit down and agree on something.
We should do that tomorrow.
Yeah,
We're doing too much stuff tomorrow, but yeah.
Yeah, I mean, we should do the stuff where we like need everybody in the same room tomorrow, and the stuff that we don't
Yeah,
necessarily.
there are just a couple decisions, I think, like how to
Yeah.
handle attributes of things, which is sort of because if you're working with coordinates, you don't necessarily care about colors, but then when you're drawing things, you might care about colors all of a sudden. So how to handle attributes, and whether what kinds of data types to use, whether things are parametric or if we just use float 64 in some places. I mean, those kinds of decisions.
Oh, yeah, well, I just wanted to address the original question. I guess I just want to kind of question the premise of like code sharing being a good thing. Because it does add communication overhead. And I just like, you know, I haven't used any, like, used the Julia graphics stuff extensively, but just like my experience trying to install like Pango and Cairo and all this other bullshit, like I lost like days of my life trying to get this stuff configured because they wanted to like share code between projects, or like this uses glib but only version 2.13 like A and not 2.14B or whatever.
I kind of agree with you, and I wouldn't describe the desired outcome as code sharing specifically. It's more having common vocabulary. So it's not that you don't necessarily want to share any code. You want to share the data structures.
Yeah.
I guess.
And maybe
It's data sharing.
We might want to share some verbs, right?
Some, yes.
You know, like plot maybe.
Yeah. I think the prime example right now is the color package, right? Any plotting package already uses the color package, so you don't, like if you have a color that works in one plotting package and another plotting package where color equals whatever, and use the appropriate color name, it will just work. Or the distinguishable colors function, you can pass that into any of the plotting packages. It'll just work. So as long as we like, it has the same data structure.
Another good example would be, for example, like, let's say you want to compute the Voronoi tessellation of something, and that's like a purely geometric problem. But then you want to plot it. Like now you have to translate from this purely geometric representation that one, you know, computational package you had to produce to whatever random representation of polygons, this graphics, and that's just, you know, massively painful and sort of annoying. And you should just be able to say, like, draw this thing for me and then see it.
Well, I suspect multiple representations of things will have to exist. Like you could have a mesh as a bunch of triangles, or you could have some special, more efficient format as well.
Right.
And that's okay.
There is meshes.jl.
Yes. Yeah.
So it's just more convert methods that are aware of more packages. Those people see needs, or I have a point in this library, I have a point in this library. One of the two should know how to convert between the two of them.
Yeah, but do you really need two different kinds of points? I mean, that's really my biggest problem.
Or line with that, probably not, yeah.
Having 5 different 2D point types is like, that doesn't seem necessary.
But you're right, you could have points that have properties, points that are just
Yeah, we've seen,
X,
there are these
Y.
cases where you might need parametric types. I mean, we had a discussion not very long ago about the fact that, right, you know, sort of for colorimetry, you know, RGB should clearly be based on a float 64, but for an image, you know, it's actually, you know, 3 UNT8s basically, right, in most cases. And so, I mean, there are cases where you want to have multiple versions of these things.
Yeah, it might be useful to have conversion functions. So if you have richer types, say you have points that also you can code other properties like colors or things like that. That could have a conversion function to spit out just raw data points. So that you want to convert from the richer to the most raw.
Seems like it might make sense to have a base API or base interface of just like plain types, and then have whatever fancy attributes you need, just grab those, so the conversion function would literally be trivial as
I suspect that any kind of attribute should be totally decoupled from geometry.
Yes,
which is basically what compose does now. You compose together the shape and the attribute. Right? It's not like one object. So.
Yeah, and I think all the geometry definitions in compose are like the obvious ones, like the point and scope 2 and some things.
Yeah, maybe the whole task is just copy those into base and then just.
Beyond there, you've run into issues like a rectangle. Is it an XY width and height, or is it an XY, or X1, X2, Y1, Y2, and some of like need a different.
I love for example, data structures that are like just going to be universal. Like if all the guys just independently went and formed their own set of data structures, like would they all come up with the same thing? We'd like,
That's true. I mean,
And maybe they just need to be in the same room and like kind of hash it out. Be like, all right, like,
Yeah, well,
I'll give you like we're using my rectangle and we can use your like triangle. I think that could be a very good outcome.
Yeah, we're in that room right now. But yeah, I mean, while there aren't any universals, but there shouldn't be unnecessary diversity either, though.
Yeah, that's one of the advantages of agreeing on something is that, if the way you specify a rectangle in one graphics package is read completely different than another one, it's just annoying when you switch graphics packages.
Why does it have to be in base either? Like all the color stuff's not in base.
Well, I was just gonna say, we could have base graphics.jl and move it out of base so that it can evolve and all that.
It doesn't have to be in base specifically. I don't care where the code is, really.
Right.
It's not so much the point, I guess.
Yeah.
Yeah, because then
graphics is in base because Jeff started writing it. That's why graphics is in base.
Is there anything in there that's worth necessitating?
I mean, there's so little, but it doesn't really matter.
Yeah, so maybe the thing to do is move that out into a package, and then all the graphics package authors can like start iterating on that, and then we'll see how the experiment goes.
Well, I mean, it's just like how in C++, if you use a couple C++ libraries, you're going to have 6 different types of strings. And which one do you use? And then
the Julia one.
And the advantage of high-level languages is if you want to give someone, an array of strings, there's an obvious thing as to what you give them. And in the same way, if you read a shapefile, there should be a relatively obvious thing that you should return that someone else can consume.
Yeah.
I think that maybe you can't do that for everything, but it should go at least some distance.
Yeah, I think it can go quite far.
I think so too. Yeah.
It's also the issue of the interface for drawing things. Like you have this in R where there's a diversity of body packages, but drawing into PNG or drawing into PDF is the same interface. So that's maybe something we want to provide.
I mean, we already kind of have that with WriteMime. Most packages you can just kind of WriteMime to an output file and it'll just work.
Yeah.
The one exception actually being PyPlot, because PyPlot actually does not return the graphics context, but it returns like a pointer into the figure. So if you call WriteMime on it, it'll just error.
I think the display API is pretty successful though.
It is very successful. I really like it. Yeah, I mean, there's issues like that though. When you write generic code, basically all packages except for PyPlot. If you want to save it to a file, I have a locally defined save PNG function that just write mimes whatever the object is to a file. It was using PyPlot and it just randomly crashed and I was very confused because it has a write PNG function, which is different because of the graphics language.
So one of the things that Tim and I have been discussing, and maybe with Jameson also, is we just need to have something that works out of the box, right? I mean, we have all these packages that do graphics, but just maybe shipping like Cairo and maybe GTK is what you've been suggesting is something we standardize on. So there's just a standard way to draw and to build a GUI and stuff. I mean, I've seen people, so I suffer through it every time. I just stopped using Winston as a result on the Mac.
Would shipping with Cairo solve those problems, or would you just still have multiple copies of Cairo?
Well, I think we do a decent job of loading up the right libraries from our paths, and that's what we used to do when we used to ship Cairo 0.1 or something.
Yeah, we shipped.
Yeah, you could do instant plots out of the box.
No,
it was on Mac. We're all the Mac package.
On the Mac, we shipped Cairo and TK in 0.1.
Yeah.
And
it was good.
And you don't have to do it on Linux. And then we didn't have Windows back then.
Yes, we did.
No graphics on it.
No, we did. That January, we were all at MIT, and we made graphics work just for the open unrelease.
Yes.
You were there.
Yes, I was. Oh yeah, there was a zip file with Cairo that we used to download. Yes, I get it. I remember.
And then you have graphics on Windows.
So it's a regression.
Do people have an opinion on this, whether we should ship a big thing or whether we should do it more Python stuff?
How crazy would it be to just have something that uses a browser, and instead of having to get all it just makes simple drafts like SVG and
I love that idea, but it seems like it's just you have to do 20 times as much work to get anything to work. It's like getting the browser to draw stuff is fine, but getting it to draw stuff really well is a lot harder. But SVG goes a long way.
I mean, IPython notebook does that, right? Except that installing IPython notebook is another story.
That's the problem.
Yeah.
It's getting the graphs to the graphs is
No, I think SVG is
maybe I just
fine.
forgot.
So drawing in the browser, I think, is a pretty well solved problem. I think it's interacting like widgets is not
getting stuff to the browser.
Yeah.
Getting back
Yeah.
So try shipping. The big problem is try shipping a plot that has 100,000 points to the browser. It's going to be slow, right? So there doesn't seem to be because you basically have to like base64 encode the data first of all, right? And then you have to make a copy of it and send it to the browser, right? And so all this is through sockets and all this kind of stuff, right? And the contrast is packages like GTK or OpenGL where you can just say, here's a pointer to the buffer that's of this size, go for it. And we really want high performance plotting of big data sets. Either we have to find a way to get data to the browser more efficiently, or we need to use something besides the browser, basically.
Okay. So the trick there is with your WebSockets, you need to set it so that it is in raw mode. So you don't have to encode the data, so you can send raw data structures, and then you can do views into the array buffer when it comes in. So if you have some standardized way of dumping a bunch of raw data,
You don't even need WebSockets for that. You could just do that where you interpret it as an array buffer on the other side. You can use straight up HTTP.
That's true.
You can't just point the browser at a place in memory, though, can you?
No.
It seems like a security problem.
So basically, JavaScript thing to do with the array buffer stuff. So like, I think you can get over, you can bring over some data, and then you can declare it to be one of the buffer types, and then you can track. It's like a union, so you can say this is a float, this is a int array, whatever. And in fact, you can start doing weird manipulations where the first four are int, considered int, and the other ones are a float.
So it's going to be a lot better than base64 encoding, but it's going to be probably a lot worse than pointing GTK at a place in memory and saying, like, this is where the data are.
Sure. I think it's going to be performed, but it's still going to be better than it's somewhere between the two. I guess the other actually, you heard me, is memory mapping a potential solution for this problem, right? If we just simply write it to a shared array and can then pass the name of the file to a web browser, does that actually get you around that issue?
Well, shared arrays are.
It's hard to pass data.
Yeah. So the browser doesn't have a shared array, right?
It's a file as far as the browser's concerned.
Yeah, but the browser's not allowed to open those.
Oh, the browser's not, okay. I think there's a lot of sandboxing. I'm not sure about NACL or some of the newer stuff that's going on where they're experimenting with ways of using browser technology, but in a little more efficient way.
Yeah, NACL is constrained by all the same sandboxing.
All the same sandboxing.
By design. The trick there is to let it execute native code without violating the browser security. So I mean, this might be a crazy idea, but could you do something that uses one of the browser rendering libraries?
Yeah,
and is
you
like
could potentially ship
your own browser.
Like WebKit or something.
You could ship embedded Chromium. Like that's what Lighttable does. The Lighttable executable is actually an embedded version of Chromium, and they embed the closure interpreter in it and then just interact with it.
Is that easier to ship than any other binary dependency?
Well, they ship it on all platforms, so it's clearly away.
So it's probably easier to build than Cairo, actually. Like it has a modern build system. So I don't know if you actually can share memory if you like do an embedded Chromium. It's a crazy idea and maybe worth investigating.
Well, it has like instant startup. I mean, I was pretty amazed.
Maybe we just do this via Lighttable if we can.
We just
shipping Lighttable might actually not be a terrible way to go.
Yeah.
Well, that is an option, right?
Yeah, I mean,
the whole point is to have like this is the thing.
Presumably you can ship a light version, right? It's just
you just have two things, yeah. I mean,
but you allow users to download the big
Lighttable version.
Right. Yeah.
It's just something so appealing of having a REPL in a terminal and opening a window. It's like, I guess maybe I'm never going to be like torn away from that, and maybe I should have been. But like, I find using iJulia a real serious problem when the data set becomes large.
Or you want to generate like a folder full of graphics, for instance, to like review later PDFs or EPS or whatever.
The result of this is like I continue to use R for all graphics, just because I need something that's like more exploratory for that stuff. And the thing is, like, I use GladFly a lot in notebooks because it's really like it actually looks in my mind much better than most of the R things. But it's hard to actually like work with a really massive data set. I guess I could be convinced that like Julia is intrinsically linked to Lighttable, but that's like one of the things I dislike about MATLAB is that like I'm intrinsically linked to this IDE.
I don't think we should intrinsically link to Lighttable. I mean, I would hate it. I would be the first person.
But I think that's something that a lot of people like. I mean, the fact that MATLAB can produce its plots and it has a debugger and all that, it sucks if you don't like those tools, but it's also a really good thing for people who don't want to make 50 decisions before they do anything. And so, I mean, maybe part of the answer is there's already Julia Studio, so either that getting pushed further forward or something like that being an option where, like, you know, if you want your whole environment, then someone's going to pick their plotting and they're going to pick, you know, their few other things, and then you can use that or not if you don't want to.
That sounds to me like it's going to be double the work, and we've already not done any of the work. like saying that we're going to ship this IDE that's really nice, and also if you want to be able to call. I mean, the other option maybe is just say like, no, you can't use graphics if you're the kind of person who's doing stuff from the rep ball. Like, but, you know, I don't know. I feel like I feel like the difficulty is like in my mind at least is that you can pitch to different audiences, and the audience that wants the IDE is often not the audience that will push the development of the language forward faster.
Yeah.
And so it's like, yeah, it's cool to do that. Actually, I mean, we had a conversation about this. I know Michael was there once at the Julia Studio. Like, I'm talking about Julia Studio, and it's like, you know, our studio is a company. And our studio is a company like now bringing in substantial amounts of money. It's like, you know, if you want to get something that's going to be really that clean, you got to be bringing in, you know, many, many hundreds of thousands, if not millions of dollars a year. And until someone is offering to do that for Julia, it's not obvious to me how one can expect a level of sophistication from an IDE, or MATLAB. I mean, MATLAB just has, MathWorks has money. It's not just like some open source project. It's not clear to me that we can live by those standards. Whereas like clearly like R, which it doesn't seem to have that kind of money, still produces quite nice graphics and uses Cairo and all these other things.
It's not completely clear to me that having lots of money is correlated with being able to get lots of good things done.
Well, it's not completely, but it's certainly very correlated.
I mean, have you seen a good open source software without money that's produced with GUI, I guess?
But also R has the benefit of having a single centralized system. There is the R graphics system, and everyone who does graphics in R just uses and develops that.
I don't think that's true.
There are plotting libraries, but
but also plotting libraries built on different primitives. Grid is not the same thing as base graphics.
But the thing that opens the window from the terminal when you look at something is that is a sort of a single agreed on.
That's what I'm talking about. And that's what I'm talking about. That thing that opens Windows and uses Cairo on Macs, that is just built into R.
Yes,
and I think that goes a long way.
It's because it's a centralized agreed on thing that like has to work.
Yeah.
And that's the benefit.
Could we agree on a thing that opens a window and then you can I mean, like, that's not super complicated.
Yeah, well, we could use GTK, but apparently people say GTK is impossible to install. So
I think we can fix that. I mean, we can work around.
It will require quite a bit of. I mean, it will require a bit of work to get GTK to work, but it will require more work to get
Why do we
anything
need
else to work.
GTK? Why can't we just like draw into a window?
Well, because you need to open a window, and opening a window is really hard for some weird reason.
And we have to write binding for XLib if you wanted to target, excess of the Cocoa and Max and Redmi.
It would show up as like this god awful thing from the 80s. The next generation's graphic system. X Windows.
That's what MATLAB did for years. I mean, they just required you to use X Windows forever.
I think that's what R does. It just has its whole own stuff.
Really?
Is that
No.
I think R is
X
something like Cocoa or Cairo. I don't know what it is, but I don't.
It's not X Windows.
It's definitely not X Windows. Well, I believe it's not X Windows. Maybe I'm wrong, actually.
I mean, it has an X Windows backend, I'm pretty sure.
It does not open X
But on the
Windows.
Mac it's...
I know this because there was a long time I couldn't run MATLAB because it kept wanting to install use X Windows and I just didn't have it.
Yeah,
and R still worked. So
But MATLAB also did away with
R
that.
has multiple backends.
Yes,
Yes.
I think ours has multiple backends.
Yeah, they develop their own multiple native backends.
And it has a native one on Windows as well.
Yeah, but do you really want to be in the business of writing yet another window?
The point is, it doesn't need to have buttons, right? Yeah, like, it just needs to be a damn window with stuff in. Like, that's it.
If you want it interactive, it's not.
Yeah, but buttons are really important. No, you need buttons.
But but you can't say, well, there's one thing for drawing, and then if you want buttons, well, you have to use something.
Yuri, you should jump in real quick. You've been patiently.
I don't know exactly what problem we're trying to solve because I don't really do that much statistical stuff, but like I just wrote a pretty simple thing that uses GLFW and OpenGL to basically take up an array in memory and show it as a picture. It's like this long. You could add user interface stuff that would probably be better than what else is out there pretty simply. With that, are there any problems that kind of approach would take care of? Buttons.
Yeah,
you can do whatever you want.
Implement buttons, button handlers, and all that. I think
you have a couple of standard controls that you want. If you want more, you can take.
I mean, because
I think the easiest thing to do
here's
is the browser.
All right. Just one last comment, and then we have to stop.
I think the easiest thing to do cross-platform in 2014 is the browser.
Yeah.
Chromium is probably the easiest thing to do. By certain definitions of it.
Thank you all for coming. You gotta get